Student, today we discuss very important chapter of mathematics part 2. The name of that chapter is circle. All of you know that the definition of the circle. Circle is in a plane from a fixed point. The set of all points which is equidistant from the fixed point is called as the circle. I will draw the figure. Now suppose that this is the plane. This is the fixed point. Then set of all points which is equidistant from this fixed point. Mean that suppose that this is the set of all points which is equidistant from this fixed point. Then this is called as the circle. And the fixed point is called as the center of the circle. All of you know that the definition of radius. This is the radius of the circle in that point which is on the circle, and the distance between the fixed point is called as its radius. If the line passing through the 2 point is called as the secant of that circle. Now this segment joining any 2 points of the circle is called as the chord. Now we can draw infinite chord to the circle. If the chord is passing through the center, then it is called as the diameter of the circle. Now if a line passing through any point on the circle, then it is called as, suppose that this is point and the line passing this point, then it is called as the tangent to the circle. All of you know that's some other definitions of the circles. Now in this we have to discuss here the first point. Let us recall for the circle. First point is infinite circles passing through 1 point. Means that suppose we take here 1 point, we can draw infinite circles. Means suppose that this is first one, as center taking different radius, we can draw the infinite circles from a fixed point. Then next one is, second one is infinite circles passes through 2 points. Suppose we take here 2 points A and B, then join the segment AB. Draw the perpendicular bisector. All of you know that how to draw. Place point here of compass, take more than half distance, draw above and below 1 arc, again place here and intersect this arc. Then this is called as the perpendicular bisector of the segment AB. Now this is the midpoint of the segment AB. Suppose this point is O. We take the distance OA and draw the circle. Then this is the circle passing through point A and B. Suppose you take any another point on this perpendicular bisector as a center and draw the circle, then also we draw one circle more. Again you have to take any point on this perpendicular, and this is suppose that radius. This point is equidistant from these both of this point by using perpendicular bisector theorem. So that suppose that this point is Q, and again you have to place point here and take distance up to this. Again we can draw the circle passes through the point A and B. Mean that the second case is that infinite circles passes through the 2 points. Then third one is, there is a unique circle passing through 3 non-collinear points. For this I draw this portion here. Now student, suppose we take any 3 non-collinear points. Non-collinear means that the point does not lie on the same line. Suppose that I will take here point A, here is point B and point C. Then when we join these 2 segments and this third one is also, then the triangle is formed. We can draw one and only one circle passing these 3 points. Now how to draw? Now suppose bisect the segment BC, mean that place point here, take more than distance in your compass, draw above and below 1 arc, again place point on C, do not change the distance. This is the perpendicular bisector of suppose that segment BC. Similarly we can draw the perpendicular bisector of AB also and AC also. Now suppose these 3 points are intersect in 1 point named as the O, is called as orthocenter. Then take distance any one of them, mean that OA, OB, OC. Then place point of compass on O and take distance up to B. Draw the circle which is passing through ABC, is called as the circle passing through these 3 non-collinear points. We can draw only one circle passing these 3 non-collinear points. So that this is our third point. There is unique circle passing through 3 non-collinear points. Then next one is no circles can pass through 3 collinear points. Student, we cannot fifth one is secant and tangent. What is meant by the secant? Now look here. First I have also tell you that the definition of secant also. Suppose that this is the circle with center anyone, suppose O. If the line passing through any 2 points of the circle, then it is called as the secant of that circle. Means that this is the secant. Can you understand what is meant by secant? If the line passing through the any 2 points of the circle, then it is called as the secant. Then next one is the tangent. Tangent means if a line passing one and only 1 point of the circle, then it is called as the tangent to the circle. Suppose that this line L is the tangent to the circle. Suppose this is the point P, means that this line L is passing one and only 1 point of the circle, so it is called as the tangent to the circle. Now we see the theorems of this chapter. Student, we see the first very important theorem of this chapter. The first theorem is a tangent at any point of a circle is perpendicular to the radius at the point of contact. म्हणजेच एक tangent आहे, ती point of contact मध्ये काय असते? Perpendicular असते. Now for this, student, I have to draw the circle and the tangent to the circle at any point. Suppose this is the circle with center is suppose O and tangent at any point. Suppose this is the point A. I have to draw here tangent at point A. Suppose that this is line L is tangent at point A and segment OA is the radius of the circle. Here is perpendicular to the radius of the point of a contact. Here is point of contact is A. So that I have to write its given. O is the center of circle. Line L is tangent at point A, at a contact point A. Then to prove is this line, the radius at the point of contact is perpendicular to the radius of the point of contact. Mean that the line, the tangent at any point, mean that this line is perpendicular to the radius. Here is OA. So here we write here to prove here line L is perpendicular to the radius or segment OA. We have to show here this line here is perpendicular to the radius OA. For this, student, suppose that we have to assume this line here is not perpendicular to the segment OA. So it's true. Assume that the line L is not perpendicular to segment or radius OA. Assume that here this is line L is not perpendicular to the segment or radius OA. Now then we have to draw one perpendicular here. Suppose we take that the segment, any another segment is perpendicular to the line L. Suppose I have to draw here again one line here. This line is L, suppose here. This is the point as O and this OA is not perpendicular, means that suppose A is at this position. Then we have to draw one perpendicular. Suppose that this perpendicular point is B. This is the perpendicular point B. So I have to write here suppose segment OB is perpendicular to line L at point B is at point B is not same as A. B is not same as A. Now we take another point here, which is, suppose that in any another point here, suppose C, such that, take point C such that AB is equals to BC. We take point C such that AB is equals to BC. Now take point. Now take a point C on line L such that A dash B dash C and BA is equals to how much? BC. BA and BC is equal joint segment OC. Joint segment OC. Joint segment OC. Now student, then there are two triangles are formed. Look at these two triangles here. In triangle OBC and OBA. Now this is the construction here. This is equal here. This is the right angle, is also construction here. Second OB is the common side. Means that these two triangles are congruent by using yes test. First we show that these two triangles are congruent. So I will write here in triangle OBC and triangle OBA. We take these two triangles here. Which segments here? Segment OB is congruent with segment OB. Why? This is common side. Then next one is, suppose we take here segment BA is congruent with segment. First I will write here BC because we take here triangle OBC. BC is congruent with segment BA because by construction. And third one is also we can draw here perpendicular here. OB is the perpendicular. Therefore segment OB is perpendicular to segment AC. This is the construction. Therefore angle OBC is also congruent with angle OBA because each 90. Therefore these two triangles, which one is OBC and OBA, triangle OBC is congruent with triangle OBA by using which test? Yes similarity test. Okay, can you understand up to this? Then their corresponding sides are also congruent. So I have to write here segment OC is congruent with segment OA. Here is reason I have to write short form corresponding sides of congruent triangle. But when you observe carefully, means these two are congruent in that they are equal also. Therefore OC is equals to OA. But OA is radius of the circle. Student look here. This is the radius here. आता इथे OA आणि OC इक्वल आला म्हणजे OC सुद्धा काय आला त्याचा रेडियस होता. Therefore segment OC is also B radius. circle in two distinct point A and C. But this is the contradiction with the definition of the tangent. Means that the line passing through one and only one point here. Means that therefore point A and C. But line L is a tangent to the circle. Tangent which is given here. It is a tangent here. Now, therefore, it intersects the circles in one and only one point. Therefore, it intersects means that the line L intersect the circle in only one point. Only one point means that in one point. Means that this is contradicts with the definition of the tangent. Means that this is our our assumption. Means that we have to assume that the line L is not perpendicular to segment OA is wrong. Therefore, our assumption is wrong. That is, our assumption is wrong. Means that we have to assume that line L is not perpendicular to the segment OA. That is, the line is perpendicular to the segment OA. Therefore, line L is perpendicular to the radius OA and hence it is wrong. Can you understand first theorem? The theorem is that, again I have to repeat, a tangent at any point is perpendicular to the radius at the point of the contact. Okay, thank you. We see the converse of this theorem. We take the converse of this theorem. Converse of the tangent theorem is that the theorem is a line perpendicular to a radius at its point on the circle is a tangent to the circle. A line perpendicular to the radius. The radius like line perpendicular. So by using this, I will draw the figure. Suppose that this is the circle. This is any center. Suppose we take here center as M. The line perpendicular to the radius means that I have to draw here the line. Suppose that this line L is perpendicular to the radius. Means that this is the perpendicular. It is suppose the point is here. On the circle is a tangent to the circle. Means that this line L is tangent to the circle. ही line L ही काय tangent या circle ची आपल्याला दाखवायचं. For this I have to write its given in the given. Now here we take as M is the center. Means that I have to write here M is center of circle. Then segment MN is the segment MN is the radius. Segment MN is radius of circle. Now here is line L is also perpendicular to segment. Line L is perpendicular to segment MN at point L. This is our given. Then to prove is that this line is the tangent to the circle. Means that line L is tangent to the circle. Then it's proved. Okay. For this we take any another point which is not lies on the circle. Suppose that this is the point P. We join here MP also. Student, when you observe carefully, MP is a right angle triangle. All of you know that in right angle triangle, MP is here hypotenuse. Hypotenuse is greater than any another sides. Mean that MN and NP. Mean that this segment is n, so that we can draw one and only one tangent to this circle. We have to write all this in such a way that then first we have to take any point. Take any point P other than that of n on line L. Then draw the segment MP. Draw segment MP. MP केला आपण draw केला. Now in this triangle, in triangle MNP, therefore in triangle MNP, angle MNP is equals to how much degree? 90 degree. Means that angle N is a right angle. Okay. Then this segment AP, therefore segment MP is the hypotenuse. Of the circle. Okay, can you understand up to this? Then this segment MP is the hypotenuse, and MP is the hypotenuse, as the segment MN is the radius. Here is segment MN is the radius, MP is the hypotenuse. We know here segment MP is greater than segment how much? MN. Now this segment MN is the radius here, as segment MN is radius of the circle. This is the given here. Segment MN is the radius of the circle. Point P. Therefore, point P means that MP is greater here. Means that therefore point P cannot lies on the circle. This point is cannot lies on the circle. Means that there is no other point except point N. There is therefore no other point except point N of the circle, of the line L is on the circle. There is no other point except point N of the line L is on the circle. Therefore, line L intersect the circle. Therefore, line intersect the circle in one and only one point. Therefore, the line L intersect the circle in one and only one point N. ती फक्त N या पॉइंट मध्येच काय करते, फक्त इंटरसेक्ट करते. And all of you know that this is the definition of the tangent, means that the line passing through the only one point, it is called as the tangent to the circle. Therefore line L is tangent to the circle. Can you understand this? And hence it is true. Okay, we use this theorem to solve the example also. Okay, we take the next theorem. The next theorem, very important theorem. This is the activity based theorem. Now the theorem is that tangent drawn from external points are equal. Here the statement of this theorem, tangent, now the name of that theorem is tangent segment theorem. Okay, the statement of that theorem is tangent segments drawn from on external point. Means that this is suppose external point D, we have to draw here tangent segments here to a circle are congruent, means that they are congruent here. Now for this I Then tangent segment, in that segment DP and segment DQ. Segment DP and segment DQ are tangents. Okay. Then to prove is that to prove. Now here is the tangent segment drawn from external points are congruent, mean that these two segments are congruent. So to prove is segment DP is congruent with segment DQ. आपल्याला हे प्रूव्ह करायचं. For this we have to make its construction is that construction. This part is not given in your book. Now first we write here given to prove, then the construction. Draw the segment AP and the segment AQ. Segment AP and segment AQ. Now this segment AP is perpendicular and AQ is also perpendicular. Now draw segment AP and segment AQ. This is our construction. Now then it's proved. Look here, it's proved. This is activity based. We have to fill in the blanks here. In triangle PAD and triangle QAD. Look at this. Segment PA is congruent with segment QA. Segment QA. Because this is the radii of the same circle. This is the radii of the same circle. Then segment AD is congruent with segment AD because common side of the triangle or common segment. Then angle APD is equals to angle AQD is equals to 90 degree. This is the tangent theorem. Tangent theorem is that tangent is perpendicular to the radius here. So that these are the tangent theorem. By using this is 90 degree. Now student, here is this is right angle. This one is the common side and this common side is the hypotenuse of that circle, hypotenuse of the right angle triangle. So that by using the hypotenuse side test, we have to show here these two triangles are congruent. Here we write here by using hypotenuse side test or theorem, we can prove here these two triangles are congruent. If these two triangles are congruent, triangle PAD and triangle QAD are congruent, then their corresponding sides are also congruent. These two sides are also congruent. So that segment DP is congruent with segment DQ. Here we write here corresponding sides of congruent triangle and hence it is true. Can you understand this activity? So simple, very important activity. Okay, thank you very much for watching the